Here's our math fact for the day. We don't have a joke, but we have a math fact. South African mathematician John Carrick tossed a coin 10,000 times. The coin landed with heads, showing 5,067 times. Now that takes some dedication, folks. Today we're here to talk about Lesson 10.5, Experimental Probability. Why do we learn this? Because experimental probability can be used by manufacturers for quality control. We're going to have two objectives today. That's to determine the experimental probability of an event and to use experimental probability to make predictions. Some vocabulary for the day. And most of these are on page 727. So for your notes, you can look in your book, page 727, to find our working definitions for these terms: experiment, experimental probability, trial, prediction, outcome, sample space, event, and probability. So these words and these sentences, these definitions are found on page 727. So please read through them. An experiment, an activity involving chance. Each repetition or observation is a trial, and each possible result is an outcome. The sample space is the set of all possible outcomes. So we've got several examples of what an experiment might look like. So rolling a number cube, the sample space, all the possible outcomes are listed here, 1 through 6, unless you have a different type of a cube or a different type of a die. Dice is plural. Tossing a coin. We have two events in the sample space, either heads or tails. And spinning this spinner, we have 4 equal outcomes: red, blue, green, and yellow. So let's identify the sample spaces and outcomes. Identify of the first one, rolling a number cube. Our sample space, as we just indicated, is 1 through 6. We can get a 1, 2, 3, 4, 5, or 6. Spinning this spinner, we can get red, green, purple, or gold. The outcome shown up here is 4. Our sample space, our outcome is green. So it's just showing you the difference between the sample space, what could happen, and the outcome, what did happen. Example 1 in your book. It says, identify the sample space and the outcomes shown for the experiment. Rolling a number cube. Well, we know those to be 1 through 6, and our outcome shown here, very fuzzy, is a 3. An event is an outcome or set of outcomes in an experiment, and probability, we all talk about probability all the time. Now we're going to have a very good definition. It's the measure of how likely an event is to occur. Probabilities are written as fractions or decimals from 0 to 1, or as percents from 0 to 100. And we talk about that probability in certain word forms. If we don't have the exact number for it, we talk about impossible, unlikely, halfway in the middle, as likely to happen as not, anywhere right of 50% is likely, and if we are talking about 90s to 100s, it is certain to happen. And there you can see those explained. Example 2 says, estimating the likelihood of an event, write impossible, unlikely, as likely as not, likely, or certain to describe each event. A shoe selected from a pair of shoes fits the right foot. Well, since there's 2 shoes, it's as likely as not to occur. We have 1 out of 2 chances. Katrina correctly guessed the last digit of a phone number. Well, the digits can be 0 through 9. What is her chance of guessing 1 out of 10 or 10 out of 100? 10% is, I guess, unlikely. Max is pulling a green marble from a bag of all green marbles. Well, I would say he is certain to pull a green marble out. And a randomly selected month contains the letter R. If you go through all the months, August, June, July, which other months don't contain an R? So there's 9 out of 12, possibly, just off the top of my head, that do. So we would consider that to be likely. We're going to write impossible, unlikely, as likely as not, likely, or certain. To describe this event, Anthony rolls a number less than 7 on a standard number cube. And by number cube, they mean dice, typically labeled 1 through 6. He's going to roll a number less than 7. That is certain to happen. The highest number is 6. Thus, it is certain the number will be less than 7. You can estimate the probability of an event by performing an experiment. Experimental probability is the ratio of the number of times the event occurs to the number of trials, the number of times that you performed the trial. The more trials performed, the more accurate the estimate will be. So here we've got our formula. Experimental probability. It's the number of times the event occurs over the number of times you performed the event or the experiment. So let's take a look at what that might look like. An experiment consists of spinning a spinner. Use the results in the table to find the experimental probability of the event. So somebody actually spun the spinner. 25 and 15 would be 40 times. A total of 40 over here. Green happened to come up 15 times. Okay, so that's what our chart is telling us. The spinner lands on orange. Well, we're going to find the experimental probability. That's 10 out of the number of trials. 25 plus 15, 40. 10 out of 40 is 1/4. And remember, we can write that as a decimal or a percent, 1/4 or a fraction, the number between 0 and 1. We could also call this 25% or 0.25. The spinner does not land on green. Now we're talking about a probability that something does not happen. So we're looking at all the alternative options. So pink, purple, and orange are not green. So we're going to add up the total of those, 10, 8, and 7, and again divide by the number of events, the sample space. How many times did the experiment occur? So 25 out of 40 would give us a probability of 5 out of 8 that it will not land on the green. You guys do the check it out problem. Example 3A. We want to know, in this experiment, what's the probability that the spinner lands on red? Make your calculations and come back and check to see that you got the right answer. So we want to figure out the experimental probability the spinner landed on red. On red, 7 out of 20 total number of trials. 7 out of 20 is our experiment. Now what we want to talk about is what's the experimental probability the spinner did not land on red? Well, that's a simple calculation now that we've got the opposite of that event. The number of times it landed on red is 7, so the number of times it didn't land on red out of 20 would be the complement to that. That would be 13 out of 20. So 7 plus 13 gives us our entire experimental sample space. 7 were red, so 13 are not. You can use experimental probability to make predictions. Prediction is an estimate or a guess about something that has not yet happened. Example 4A. A manufacturer inspects 500 strollers and finds that 498 have no defects. What's the experimental probability that a stroller chosen at random has no defects? Well, we're not going to go in and run the experiment. We're not going to pick out a stroller and see if it does. We're going to go with this statistic up here. And what is our probability of selecting one that has no defects? That would be 498 out of 500. And we would simplify that or turn it into our percentage. 99.6% of the strollers have no defects. The experimental probability is 99.6%. Manufacturer inspects 500 strollers. The manufacturer shipped 3,500. We still have the same statistic. So 498 out of 500 have none. But out of 3,500, predict the number of strollers that are likely. So we're going to use the experimental probability statistic and make a guess as to how many might have defects out of 3,500. We're going to find 99.6% of 3,500. That will tell us the number of strollers that have no defects out of 3,500. Showing you the math, changing our percent into a decimal and multiplying. 3,486 will have no defects based on the experimental probability that we found earlier. Let's check it out for A. You guys read through this. We're inspecting 1,500 electric toothbrushes. We find 1,497 to have no defects. What's the probability that a motor chosen at random will have no defects? Work that out. Come right back. So finding the experimental probability that it has no effects, we're going to take those defect-free toothbrushes and put it over the total number of trials and finding 99.8% accuracy in creating an electric toothbrush without defects. Well, we're going to take that statistic, that experiment that they did, and make a guess out of 35,000. What's the likelihood that the toothbrush has no defects? We're going to take our original statistic and find 99.8% of 35,000. Looking at the math, 0.998 times 35,000, 34,930 toothbrushes will be defect-free. Here's your quiz. I'd like you to do these problems. Problem number 1. Here's quiz question part 2. An experiment consists of spinning a spinner. Use the results in the table to find the experimental probability of landing on blue. Answer this question. We'll check all answers at the end of the quiz. And part 3 says the neighbor's dog barked at Tana the last 4 out of 5 times she walked by their house. What's the experimental probability that the dog barks at Tana when she walks past? Predict the number of times the dog will bark if she walks past the house 45 times. Go ahead and answer that question, and we'll come back to the answers. For part 1, it says identify the sample space and the outcome. Sample space is red, green, and yellow. The outcome, the one that they've selected, is red. Question number 2, it says we're spinning the spinner. What's the experimental probability of landing on blue? That is 6 out of 20. We're going to reduce that to 3 out of 10. And part 3, experimental probability, 4 out of 5, 80%. The dog barked. What if she walks by 45 times? We're going to find 80% of 45, 0.85 times 36. Your assignment is on PowerSchool. It's also written on your Canvas. So go ahead and get those problems done and turned in.